Hey guys, today let's look at Lintcode problem number 28. Search a 2D matrix. Write an efficient algorithm that searches for a value in the n by n matrix. So this matrix has the following properties. The integers in each row are sorted from the left to right, and the first integer of each row is greater than the last integer of the previous row. Let's take this example. So this is the given matrix. What do we have? And we need to search if target 3 is in this list, in this matrix or not. And we're going to just return true because it exists. And the challenging part is that we need to finish this using log n plus log m time. So this is quite challenging. That's how we're going to do this. First things first is, we need to say what kind of data structure we can use in our situation. First, we have some keywords, right? We need to do a search, so this is a search problem. And second, we need to satisfy this time complexity, which is log level. Search plus log, actually this leaves us almost no choices but using binary search. Because if you use a binary search, you're going to definitely have this log n, log time complexity. But another question is that, a problem is that binary search is only applicable for a one-dimensional array. But in our problem, we were given a 2D matrix. So how are we going to do this? So one natural thought is that can we just convert our matrix to a one-dimensional array? The answer is yes, because we have two properties of this matrix. So each line, we can say each line is sorted. And second is that the first element of each line is always greater than the last element of the previous line. So which makes perfect to convert it to the one-dimensional array. So for example, we're given this matrix, we can make it one-dimensional array like this. After this is done, the question has become, we just do a search on this array and try to give the answer true or false if the target is in our matrix. And the third thing is that how we resolve the coordinates conversion between the one dimension and two dimension 2D matrix. This part actually is easy. Alright, so let's look at the code. This is the entrance. We were given a matrix and we're given a target. First, we're going to just do the parameter checking. If this matrix is empty, then we're going to just return false. And here we calculate the dimensions m and n. M indicates the rows, n indicates the columns. And we define a start and end. So this part, from this part and this part, this is the binary search template. We're going to use this template. So by using this template, we first have to have the start index and have the end index. And actually indicates the last elements in the array. So we convert it to a one-dimension coordinates is going to be m by n minus 1. So once we have this, and this is a while part. For while part, we have the condition, which is start plus 1 less than end. This means what? This means that we only deal with the array, more than 2 elements. Then we're going to just do this binary search thing. If there are only 2 elements, we just it can be included in this case, because we're going to just check the end at the very end of this after this while section. Alright, so let's take a look into the while. First, we calculate the middle element, start plus n minus star divided by 2. Actually, this part I need to mention that this is the best way to calculate the middle, because if you use Java, you may face the issue of overflow. So that's why here we just use this minus n minus star and divide it by 2, so this part won't overflow. So someone was probably they use this thing. They use this formula: star plus n minus 2. But if the start and the n, they're very large integers, if they are you do the addition, they probably just overflow. So this is better. So when you do the interviews, just tell it to your interviewer, you will get some points. Alright, so first we're going to just compare these middle elements with our target. If the middle element in a 2D matrix equals to our target, if it is, then the search is done, which is to return true. If not, we just try to compare if it is greater than our target. It is great, then we're going to just adjust our upper bound. We just assign our middle to the end. If the other way, if our middle element is less than our target, so we're going to just adjust our lower bound, which is the start part. So when this part is done, we still left two ends not checked. So we checked the ends separately. First we check the start. If the start elements equals to our target, and then we check the end. And after all this, while and two if blocks, we just always return false. That means we didn't find our target in the matrix. And for the coordinate conversion, it is happening here. So for this one dimension index, we just divided by n, we got the row number, and we modulated by n, we got its column index. So we successfully just map it to the 2D matrix. Alright, so let's test this. Right, so sometimes this Lintcode is slow. We need to just wait for a while. But all in all, this is great question. It is meaning focus on the binary search, but they make it a little bit complicated because this is for the 2D matrix. So we have to convert the 2D matrix to a one-dimensional array, and we have to take care of this coordinates conversion between the 2D and 1D. So for the input, alright, something happened. So that's interesting. Output here. Because if this matrix is empty, you got to return something. That's what happened. I didn't return anything. Alright, so looks like everything is right. Yeah, that's today's algorithm, and thanks for watching. If you like it, please subscribe. Thanks.